9.1.2 says calculate the coordinates of P and R. Now P and R are your turning points, or otherwise known as stationary points. In order to find these points, it's important that we get our first derivative. So our first derivative can be gotten from our original function, which is x cubed plus x squared minus 16x plus 20. And to get the first derivative, that would be 3x squared plus 2x minus 16. And then we know something about these stationary points, these turning points. They have a gradient of 0. And we know what gradient is. Gradient is the first derivative. So basically, in this case, we're using g. If I can say that my gradient is equals to 0, that's the same as saying I'm looking for the x values where my gradient is 0. So you make you get your trinomial like this and you equate it to 0. So what this says is, for which x values of this function will the gradient be 0? And we know we are supposed to return 2 values, and since this is a trinomial, we know at most we can get 2 values out of this. So at this point you can use your quadratic formula, or you can try and solve it using factorization. Since the quadratic formula is just plug and play, I'll just keep the formula over here and you can use it if you want to. So it's minus b plus minus b squared minus 4ac all over 2a. But then here I'll use the factorization method. So open up 2 brackets, equate them to 0. This is supposed to give us 3x squared. So somewhere here we're going to have a 3x, and over here we're going to have an x. And then we need to find factors that we can add for plus 2. But when we multiply these, we're not supposed to get minus 16, but rather 16 times 3. So thinking hard about it, we have 8 and 2. 8 and 2 factors of 16, right? We also have 4 and 4, but we can't use 4 and 4 to create 2. We can use 8 and 2, however, to create 2, and that will be as follows. We can have 8 and minus 2, so plus 8 and minus 2 is a combination that can work, because 3x times x gives us 3x squared. Then 3x times minus 2, that gives us minus 6x. Then 8x times x, 8 times x, that gives us 8x. So 8x minus 6x, that gives us 2x, and that holds true. And then minus 2 times 8 will give us minus 16. Therefore, you can now equate these individual brackets to 0 to get 3x plus 8 is equals to 0, or x minus 2 is equals to 0. Taking 8 to the other side, you get minus 8 over 3, or x will be equal to 2. And you choose, well, you don't choose, since here they want both of them. So the negative one will be for r, the positive one will be for p. For p, at least we know it's on the x-axis. So its coordinates is going to be just 2s to 0. But then for this one, we need to put that into our formula, into our original formula. So we need to find g of minus 8 over 3, and that will be equal to into the original formula, not the derivative one. So that will be equal to minus 8 over 3 cubed plus minus 8 over 3 squared minus 16, 8 over 3, negative 8 over 3 plus 20. And putting this, you get 1372 over 27. Then those are your coordinates for r. So that's minus 8 over 3 and 1372 over 27, like that. Those are your 2 coordinates.